Welcome to our exploration of quadratic equations. Today we'll learn about their definition and standard form. Let's start with the most important feature of quadratic equations, the x squared term. This term is what makes an equation quadratic. Here are some examples of x squared terms. Notice they can have different coefficients, including negative ones, but they must always include x to the power of 2. Now let's look at the standard form of a quadratic equation. The standard form is a x squared plus bx plus c equals 0. Here, a is the coefficient of x squared and cannot equal 0, b is the coefficient of x, and c is the constant term. Let's practice identifying the coefficients in some examples. In the equation 3x squared minus 5x plus 2 equals 0, we have a equals 3, b equals negative 5, and c equals 2. Here's another example. X squared plus 7x equals 0. Notice that a equals 1, b equals 7, and c equals 0 since there's no constant term. One key characteristic of quadratic equations is that they typically have two solutions. We can visualize this by graphing the quadratic equation. The graph forms a parabola. The solutions are where the parabola crosses the x-axis. In this example, the solutions are x equals negative 2 and x equals 2. There are four main methods to solve quadratic equations. These include factorization, completing the square, using the quadratic formula, and graphical methods. The quadratic formula shown here is particularly useful as it works for any quadratic equation. Let's summarize what we've learned about quadratic equations. Quadratic equations have the standard form x squared plus bx plus c equals 0. The essential x squared term creates the characteristic parabolic curves when graphed. And most importantly, quadratic equations usually have two solutions. Thank you for learning about quadratic equations with me today.